Let's take a look at Project 4 for Algebra 2B. This is the last section of the project. It corresponds to Lesson 20. So we are continuing with Digit and Polly's spinner game and card game that help determine the food that Gormando is going to get. So this time we are incorporating money into the game, and we're saying, well, what if Gormando had to pay $2 to play Digit's game with the spinner? And based on what he spins, he gets different money amounts. So if he spins cured pasta and bear, he gets nothing. Lime and mutton, he gets $2, etc. So now each spinner section also is associated with prize money or not. Maybe he wins nothing. So we have to determine whether the game is fair by finding the expected value or expected cost for Digit's game. Now I'm just going to help you on figuring out expected value, and I'm going to leave it to you to interpret the results of the expected value and figuring out whether or not the game is fair. Hopefully you took good notes on Lesson 20 and you remember already having looked at expected value examples and what it means for some probability game to be fair or probability situation to be fair. So if I want to find expected value, here's what I'm going to do. I'm going to take, in order, I'm going to start with the cured pasta and bear just to make it easy. In order, I'm going to take each of these. I'm going to take their probability, so you would take, and I'm just going to take kind of a key letter, so probability of, let's do P for pasta, probability of M for mutton, probability of what? A for alligator, and so on, right? And then maybe C for chicken. I'm going to write a little closer together now. Wafer, probability of the wafer, plus let's do G for gooseberry, and let's do A for apple and lavender calzone. So first thing I'm going to do is, notice I'm just setting up kind of a skeleton, and then I'm going to multiply out in front of it the numerical, the money value. So let's do, I'm just going to write an M for money. So you would multiply the money winning amount for each of it, and it's going to be a different number. So this would be the money associated with P, the money associated with M, the money associated with A, the money associated with C, the money associated with getting the wafer, the money associated with that gooseberry thingy, the money associated with the apple and calzone thingy. So this is your framework. So when you're actually writing it out, for example, and I'll just write the first term for you, and I think you'll get the hang of it. So again, you're going to have the money value, so $2 could be 0, the $3, the $7, $2.50, all that, right? Those are the individual winnings associated with each thing. That multiplied by the probability of getting that item. And I'm going to do that for each individual item in the order that I see here. And you're just going to add them all together, and that's going to give you the expected value. So for example, I'm going to look at this cured pasta and bear section. So the money associated with that, he wins nothing if he gets that, right? He wins nothing. So I'm just going to have a big fat 0 multiplied by this probability. The probability of getting this, it's on one section out of 12, so this probability is 1 over 12. So that's the first term in my thing here. And now I would just continue on that way, plus the money associated with, if he spins baked cucumber and lime mutton, he wins $2. So that'd be a 2 out in front, and then the probability of getting this, it's labeled on 2 sections, that would be 2 out of 12. And you would just continue on that way. Look up what the money is associated with spinning the poached fennel and alligator, and then multiply it by the probability of getting that. And just go all the way down the line. That's going to give you the formula for expected value once you have all that whole thing put together. And then you can simplify and see what your expected value or expected cost is for the game. Next, explain why you think Digit's game is fair. Use the information from the previous slide to help inform your answer. And again, I'm not going to totally give away how to interpret the results. I want you to look up the example from the lesson if needed. But what do you do with the results of that expected value formula? How do you know whether that means the game is fair or not? Next, for one of the games, the only rule is that if Gormando gets a praline wafer for drawing a card in Polly's game, he gets $6. And if he draws anything else, he wins a 0. So this is just a weird, kind of an odd little game, isn't it? So he either draws the praline wafer, which is right here, draws that and he gets $6, or he gets nothing. So the question is, how much does he need to pay Polly to play the game in order to make this a fair game? So that's related to the odds of getting this card. So the card is a diamond, he gets a praline wafer. All right, so and the odds of getting, the probability of getting that wafer, as we've discussed before, is a 1 in 4 chance because a quarter of the deck is diamonds, right? 13 out of the 52 cards are diamonds, so there's a 1 in 4 chance. So since our probability is 1 in 4, our probability is 1 in 4, and our winning, what we would win, would be $6. What would be a fair amount to charge in order for this to be a fair game? It's going to be 1/4 of what Gormando could win. So what's 1/4 of $6? And here's why that kind of makes sense. What we're saying is, since there's a 1 in 4 chance of winning, theoretically, right, if I played it 4 times, I might win. Now, we don't want to fall into the gambler's fallacy, which tells us that it's kind of like, imagine I'm playing a game. In fact, let's use the same odds. Imagine I'm playing a game that has a 1 in 4 chance of winning, okay? So again, imagine I'm playing a game that has a 1 in 4 chance of winning. And I'm going to play the game, I don't know, I'll play the game 4 times. So, when I play it the first time, I lose. When I play it the second time, I lose. When I play it the third time, I lose. When I play it the 4th time, what will happen? Well, you might be tempted to say, oh, you'll win, but that's not how probability works. Each one of these individual games, I have a 1 in 4th chance of winning. So just because I lost 3 times in a row doesn't mean I'm due to win. It doesn't mean I have a higher chance of winning at all. I still only have a 1 in 4 chance of winning this game, right? Now, as I play more games, we would certainly expect to see a quarter of the games be wins if it's a fair game, right? But if I'm just looking at this small sample size, knowing that I lost 3 times in a row doesn't mean anything about the 4th game. Rather, when we're talking about this over here, and again, that was the gambler's fallacy, okay, that they feel maybe due, like they're due for a win, or that their odds of winning go up the more times they lose. Those are just logical errors. The reason that it would be a fair game if we pay a quarter of the winnings to play the game, just think about it in a more intuitive sense. Okay, so if there's a probability that of a 1 in 4 chance of winning, then it makes sense that maybe if I played the game 4 times, I would win. So when you kind of think about it from like a break-even perspective, if I continue to play and play and play and play, I'll have won 1/4 of the games probably, right? So it makes sense that my investment would be equal, and that would be kind of like a break-even point, okay? So again, if that didn't make total sense, that's okay. But again, it makes, we'll say that if the probability of winning is 1 in 4, and the amount of money that you win is $6 or nothing, then a fair charge to play the game is to play a quarter of the amount of money that you could win. So you'll have to figure out what a quarter of $6 is. And last, explain your solution to the previous question in detail. Include your calculations. I will be grading to make sure that you included your calculations. So again, I kind of explained it, and I didn't do it in strict mathematical terms. I gave that example, which was kind of a side note more than anything of the gambler's fallacy. But again, explain your solution to the previous question. So how much money should you have to pay to play this game based on the fact that the probability of winning it is 1 in 4, and that if you win it, you'll get $6. So just, again, I don't expect you to present a perfect formula, but just describe to me as best and as clearly you can using mathematical language how you arrived at your answer. And again, I would think that the explanation as well as including your calculations will probably take you maybe 4 sentences or so to accomplish. As always, think of it kind of like a discussion post.